But yeah, I was going through, and we are live. Oh, now we're live. Anyway, was going through the book again and like hand going through and like doing all the calculations by hand, which was pretty interesting. Mainly because that what was it? Fermat's little theorem, which page 14, right before exercise 8. Oh, it talks about the finite field division. Fermat's little theorem, which the negative p minus 1, like when you raise it and you do modulo exponential, it just equals 1, like the whole. And that was like the last thing I did is I like was writing out exponential modulo, but just to the prime minus 1, which the prime number is also the order of the set or the finite field, right? Anyway, thanks to anybody out there. Oh, right. But then it gives it. This was the thing that we were getting tripped up on, is it allows you to get to the division, which was like p minus 2, like exponential, like exponent p minus 2 is the division part, if that makes sense. So yeah, and then you multiply 2 by 7 raised to the prime minus 2, and then you mod that again, whatever that answer is, because you're modding everything. Super mods. Where did we leave off? Because it wasn't on this. We coded all this before. Did we? Let's get to the end of chapter 2 then. Did we finish chapter 2? Let's see. So, okay. So do we have the point? Oh yeah, we had point addition, right? Oh no, we didn't. I didn't push this code up. Oh no. Shame on me. Yeah, dude. And that shows up on GitHub too. So no, it just shows let me see here. Oh yeah, I guess it would be a green dot in your grid or whatever. But I know yes, sir. No, it just shows that you like contributed to the code, which is kind of cool, and that's a live share thing. So if we look, yeah, yeah, yeah. So I thought that was pretty cool. Where it's only at infinity, right? Right. Right. Did you read ahead to chapter 3? It was interesting. So define some of these elliptic curves. And the whole type is like we're moving into the actual like cryptography that makes Bitcoin crypto, which is not crypto. It's cryptocurrency. It is a cryptocurrency. It uses cryptography, but it's not crypto. But yeah, so this is very distinct. Yes, it is different. It is different. Yeah, I went over this the elliptic curve that, or the formula that Bitcoin uses for its elliptic curve cryptography, which was the SECP 256K1, I guess over real numbers. And then did you look into this? This one was super interesting. So instead of doing real numbers, right? So that's what this shows here is real numbers. Which I'm not like a super math guy, but like the real number part is, I mean, it's a number. It's like negative numbers and like decimals and all that kind of stuff, right? It's like all everything you think commonly as numbers, I think, are real numbers. At least, right. Outside the scope of this stream, hopefully. We deal with finite fields here, right? Where we know exactly what's in those because we mod everything. Well, they can be, yeah. The very large primes. Yeah. And it talks about doing this, where you define an elliptic curve over a finite field. And all that means, though, is instead of, because we defined we defined addition and subtraction and multiplication and exponential for our field elements, right? And then we defined these addition that we needed for a point on a curve. And so whenever we do this formula, we just use like the math that we defined already, the finite field math. Where was that at? Oh, yeah. Yeah, I get you. Like basically, it's not overloaded. What is that term? There is it's a programming term. It's not method overloading, because I think that has to do with like signature parameters. It is overriding? Override. I thought there was a specific term for it. It doesn't matter. But yeah, you're right. We redefined like the plus, minus, multiplication signs, which allowed us to use all of the use the symbols in our tests. Right. Oh, here it is. Yeah, coding. Because we define the elliptic curve point and define the operators, we can combine them. The addition. And so now, oh, hey, look they have us writing tests. That was another thing that I got pretty excited about. Like the test helper library? Okay. Yeah, I don't. Huh. Yeah. Test on curve. And we can just do, we'll implement these tests that they wrote. So we have these ECC tests, and I don't think we need it. Is it overload? Is that the term? Right here. Ah, okay. Right. So what I think we're going to do, though, is I think for this... Oh, okay. All right, so we're going to have to do a couple things differently here, because now... So in Python, because it's sort of dynamically typed, it's not statically typed, they just pass in, instead of... they just pass in, make X and Y field elements, right? And they make A and B, they just make them field elements. The problem with that is when we defined our point class, we didn't define those as field elements. So we'll have to kind of update our definition of the point class, and we could probably come up with a better name for it than just point, elliptic curve point, or ECC point. I'm open to ideas. We could just leave it called point, but we're gonna have to update the type definitions of these different pieces of the actual struct, right? So like right now we're using a float 64, but in this, go ahead. Right. Yeah. So you can try. So you could do point. We need to import it though. Oh, I see what's going on here. So I'm pretty sure this is, new. But it'll yell at us if we do that, right? Because it has to do with the static typing of Rust. So yeah, it won't work. Right. Yeah, it's a feature not over. Give me 2 seconds. I'm gonna go grab my other keyboard. I forgot the shift. I've not used this laptop since we streamed last, and I forgot my shift key is broken. So give me like 2 seconds. And I have a sneaking suspicion that Santa is bringing me a new laptop, but, he has not arrived yet. Oh, yeah. Yeah, well, let's see, in 3 days, my youngest will be 3 years old. Yeah. Yes. Yes, they are static. Okay. All right. Now we're back in business. But yeah, this we can't. We have to redefine point. We can do that in a whole new class if we wanted to. It'd probably be faster just to refactor using like VS Code's refactoring. So like F2 allows you to sort of update. Oh, I thought it would be. Maybe not change signal. I thought F2 would let. No, guess not. Is Rust Analyzer up and running? Yes, it looks like it. Okay. That's cool. Just giving us some. Oops. I thought it would be easier to just rename these, but. Nope, refactoring doesn't let us. So we'll just change it by hand. Right, yeah. We're not going to need, I don't think we're going to need like a point class that doesn't have field elements in it, right? Because ultimately we're programming Bitcoin here, so there's not like real numbers being used for these elliptic curve cryptography. And then it doesn't implement copy, so we have to go update this definition. So the compiler was sort of yelling at us. I do, yeah. She sounds lovely. Please do, yeah. We see one day we'll have to get our wives together. My wife's a classically trained opera singer. Okay, so this is considering annotating field element with clone. Oh, okay. It's just saying that we need to add clone too. All right, so this satisfies. So basically what happened is we were deriving copy, and copy was not happy with being derived on point because field element, right, which is a subtype within the point, didn't also derive copy and clone. Right, so the compiler yelled at us a little bit because it says, hey, no, I can't copy or clone this thing because the underlying types, like the nested types, didn't derive clone. And that shouldn't give us too many problems. All of our problems lie in point.rs, which, by the way, so VS Code will give you this nice little like outline of all the things that are wrong in your code base that the compiler has found. And yeah, it's pretty nice. It expects the field element struct, and it got an F64th. This is just because we haven't gone through an update. So if you could start at the bottom of the file and go through it, and anywhere you see, that we're using a float 64 or an I8, yeah, we're just going to update that to being a field element. There's probably a quicker way to do this. Yeah, that's what I was thinking, yeah. I don't know. Okay, so maybe we should do these together then. I don't know, because I don't know what you're looking at. Let me go. We can do find and replace one by one just so we're finding them all, I guess. Or no, we can do it by hand. So the first is the new function. So yeah, X, Y, A, and B are all going to be field elements now. Oh man, okay. This is going to get interesting. Because now we have to define a infinity point as a field element. Yeah. So what is in a field element? We have uSize. So going back to the infinity point or the identity point of the curve, wasn't that just the 0 point of the curve, or no? And it gave us a none. That's what it was. So in Python, it was using a none. We got cute and used infinity. Let's see if Rust Rust uSize maybe has an infinity. Maybe not. Yeah, no infinity for uSize. So if you use U64, I'm trying to think of because we just need a way of representing it. And I don't quite know what a good type is to represent infinity on a field element. So let's go back to uSize, the type definition for it. No, float64 has infinity. Yeah, it's only the float numbers have infinities. So uSize will just it will. It's like a variable, like depending on how you compile it, it will sort of change, if that makes sense. So it says it right here in the definition. So on a 32-bit target, so if you're compiling for 32-bit architecture, it's 4 bytes. If you're compiling for 64-bit architecture, it's 8 bytes. But you can use uSize, and then it will just like automatically, depending on what you're compiling for, it will automatically do one or the other sort of thing. But there's not a way. Yeah, I feel like we should have looked. I should have looked this up, and I apologize. So maybe, okay, so I guess we can do something called a result. Is it result or no, it's not result. I think it's option. Result is like either it's okay or there's an error sort of thing. I think option, yes, okay. So option here is there's either none or there's some. So if we convert the number itself, because that's what we were, right? Yeah, the number itself. We'll never have none as a prime. So if we do option of usize, now there's a bunch of things that have broken. Right, you do get an optionality of none, but now you have to kind of explicitly handle it, if that makes sense. So right here, it's already complaining, right? So it's, you know, well, first it gives a suggestion. It says try wrapping the expression in sum. And basically what's happening is it's prime is a usize, and it's trying to do a comparison to num, and so it's not liking that. But if we do this, as it suggests, oh, whoops. Maybe it's like this. Is that what it's suggesting? But that doesn't make sense. We don't want that. I don't know how that works with the comparisons, having some. So we're going to do something kind of dirty, which is unwrapping, which I think we talked about it a little bit before, but it's just like, hey, just give me the value. Like, don't, just give me the value or not. But we can also unwrap, or probably should just check. We probably should just check to make sure the num is something. Okay, I think we can do this. We can do unwrap or, and then if there's nothing there, we'll just do none. Which that doesn't make sense. Arguments, mismatch types, expected use size. Oh, okay. I see what's going on. Oh, wait. I know what we're doing. We are going to do a match on this. So match is kind of like, you can have like two branches of the function, sort of. Not the function, but like whatever you're matching on. And you can see right now that it kind of yells at us where it's missing two different match arms. There's the none match arm and then the sum. And this is what, like, so match, if you match on something, it forces you to handle every single option or every single arm of the match. So if we matched on like an enum or something like that, it forces you to handle every single case. I think this is where my syntax is lacking. I always forget, like, is it a fat arrow? Is it a skinny arrow? Okay, it's a fat arrow. So, all right, if there is some there, then we return self with X there as prime. That should be good. Why is this not working? Let's see. Oh, because we made it an option. Wait, then why didn't this work? Oh, we needed to check the... My bad. We don't want to return. We forgot the original check where we need to check if the number, like if the number is greater than or equal to prime. That's not good. Whoa. So we can do X. And then this should work now. Oh, because we have to do this. All right. So here we go. This is what I was ultimately trying to get at. So if there's a number there, if there is some there, that means that means X has a value. We compare it to the prime and we do the check to make sure that it's within the range of our field. And then we return sum of X, right? Because we want num to be an option. I have a quick question. Are you able to do push to talk at all? It is, yeah, it's a bit distracting. No worries. What, on Keat? There's no, oh. All right, Keat.io. Go implement push to talk. Okay. So with some, we handle that, and then the compiler's yelling at us because we didn't handle none. And we can quick fix it, and it kind of gives us a cute little to-do macro, which is fun, sort of. Oh, nice. Hey, never mind. Good job, Keat.io. Nice. Okay, so if it's none or null, that's the infinity point, right? So we can return in this case num is none, and so we just return that infinity point of field where we have now a quote unquote null, but now we can handle the infinity point. I'm curious though, because now we're probably going to have a lot of other issues where we're going to have to handle that optionality of the number itself. And the first one comes up where we try to raise it to the power because we don't have a number. So let's see, to the power of. Okay, this should be simple enough. So we can do another match here on self.num, and the easiest thing is if we have none. Maybe not the easiest thing, but if we have none, we just return, because it's the infinity point, right? So the infinity point to the power of anything is infinity. Like infinity times anything is infinity, right? So I think it is safe. Uh-oh. I'm sorry, I kicked you out of the chat. I was trying to not follow you. Or not out of the chat, but yeah. Out of the live share. But yeah, if we have none, it's infinity. So we can just return none, or return itself, sort of thing. It is, yes, hands down, way better. And you sound way more crisp and clear. Yeah. I'm hoping you're coming through on the audio mixer, actually. Yeah, we might not even have... Hold on. Yeah, I don't think I'm getting any levels from you. Oh, no. Yeah, but I don't want it just to be me talking to myself. Let me add an audio source. Maybe I have to add Keith's audio source? Or the headphones?
Yeah, I guess that would work.
So, try talking now.
Talking.
Hey, there you go. Yeah.
Going in there now. Nice.
I had to add the my headphones as an audio source. So I apologize to listenership for our fiat production quality here. All right. Anyway, so we matched on the none, and we're just gonna return self trait bound options. One is what? I think this is yelling at us. It doesn't like. I don't know if this is redundant or if this is necessary. I didn't take too long to read it, but the compiler likes it better, so that means it's probably more better.
More better. I like that.
Yeah. Okay, and then
is match kind of like switch?
Yes. Yeah. Very, very similar to switch. Yeah. I mean, I don't.
Okay, good. I like that.
Except it does. It's like way. I mean, because if you look over here on the left hand, on the left hand side, all these examples, right? Like you can match on several numbers, or you can match on like a range, and then there's like this default case sort of thing, which it will yell at you if you don't have. Right? You can match on a Boolean if you really wanted to.
It has more flexibility.
Right. Yeah. It was something that caught me up actually in my last job. Which, by the way, anybody watching this, I am for hire now. So there's a headcount reduction at my last job. Luckily, we started this, so I have a little bit of proof of work that I can put out there. But yeah, at my last job, I was working with Java, and Java like has like this default case thing with switch statements that like sort of trip me up. But anyway, we're here to talk about Rust, so I don't want to talk about Java. I was not a fan of Java necessarily. I'll go write it again if it pays the bills, but
it's good that you're focusing on more modern languages.
Right. I mean,
Rust, yeah.
Well, I mean, Rust or Java runs the world, so it's not the worst thing to know. But okay, so here it is.
I was watching this video. Quick parenthesis. You know those info videos with the bars that go switching, like going up and down over time. And just came out today about like the most used languages. And yeah, there was a time it was Java on the very top
Oh yeah.
in terms of most users. Now Python is up. It's
Yep.
been for a few years, but Rust is just growing really fast. It might be in like 4 or 5 years, maybe Rust will be in the top 3 or so.
Yeah, I mean it goes the breadth of what you need it to do. I mean, you write a web server in it, you can write a front end in it. You can write microcontrol like small little like circuit board code for it. It's got a lot of like memory safety guarantees. It's a lot easier to learn than like C++. This is all my understanding, right? So don't trust, go verify. But yeah, it was cool. I actually got to what's up, Greg? First time in the chat. Welcome. I had a great conversation with Greg recently. Awesome Bitcoiner out of the Midwest, if I recall. But cool dude.
Welcome, Greg.
You're here checking it out. We're talking about the laudable aspects of Rust. But I met with a guy named Hunter. He's in the Bitcoin community, but also runs like some Rust Telegram groups and stuff. And yeah, he was like, "Hey, just go find an open source repo and write some code and then turn that into a job." So we'll see how that goes. Did you see what I had to update here though, with as far as like the numbers now that we have this option as our number?
Mm-hmm.
So
So you're basically adding how each function should interpret when the number is none in this case,
right,
which is our infinity.
right, which is also called the identity point. And we're referencing this book called Programming Bitcoin for Greg that just joined us. Go buy the book, support Jimmy's song. Jimmy does awesome things. It's been a great book so far. But yeah, and then we've got a couple more issues here. Okay, so we've got this sort of okay. So this is just saying that the option doesn't have the display trait on it. So we can try to use these. So we'll try to use that first and see how that goes. It's kind of like, so with the question mark, from my understanding, if I recall correctly, it's like a debug printing, if that makes sense. What did it describe it as? Let's see. What it was for pretty print. So yeah, I guess it's called pretty print. But yeah, it's this colon question mark. And I'm sure
this ain't that important because you're mostly formatting the string, the identifier for the class, right? It's not an operation per se, right?
No, yeah. This is
like just leave this string blank or whatever.
Right. Yeah. This is if we wanted to print the output of it, like to the console or whatever, which can be useful in tests or other, times. And so yeah, let's keep moving down here. We'll see, I'm sure, some more issues. So this here is an issue because we have option plus option. So this is going to be interesting. So we can't add two.
No. Have three possible combinations there.
Mm-hmm.
None plus none, none plus some plus some.
Well, and this goes back to the addition that we had for the infinity point, I think, right? Because this is the definition of adding, right? So this is adding for a field element, but now that we have this essentially an infinity point for the field element, we need to figure out how to handle that. So all right, let's go back to the Bitcoin programming Bitcoin book. When we added that infinity point, do you remember what the output was for that? Because that was like a I guess we just look at our code.
Wasn't the result of adding the infinity point to something? Like it just returns the self.
Right, yeah, that's right here. So we need to update our field element to handle this infinity math, which kind of sounds weird to say. I'm trying to think if this is the right thing to do or not, and only because this is, I'm hesitant to modify the addition properties of a finite field or a finite element, even though, only because the point, oh, you know what? I think we're going about this the wrong way. So I think that X and Y should be an option. We shouldn't mess with field element at all. Right? Because the infinity point is only relevant when we're doing point addition, subtraction, multiplication, etc. But it should have zero impact on the field element itself. Does that make sense?
It does.
So I think we went about this the wrong way.
Yeah, we didn't talk about point at infinity during finite fields, because it's literally the point at infinity.
Right. So we would need to, which luckily we have Git, which it just shows us that we did all these changes, and then just a click of the button and we're back to where we were, which is fantastic. Yeah, so we'll just leave field element alone, because really the infinity point is only relevant for points. And so this can become an option of a field element. And then this is going to yell at us about something. Trait, yeah. Oh, okay. So we do need to update field element to, we forgot we reverted that change. So we'll go ahead and update that. Okay. And so these become options of field elements as well for creating a new point. We can just go ahead and do this. And this is where, I wonder if this is where we can do the check is none. So if it is none, then that means it's an infinity. I think. Yeah, that makes sense. Because we have an option. So if X and Y are the none option, then we just return itself, because it's the infinity point or whatever.
Yeah, I
However,
remember that. Yeah.
yeah,
It's when you have the infinity point, you want to return the function before it checks to see if it's in the curve,
right, right, right,
which is
right.
the next if statement there.
And then this is going to be interesting now because we used to have to cast these. So I don't think we have to do that necessarily anymore. But we have this issue here where, so we still have an option. We still have yet to handle whether, well, okay, so so we actually are handling it. We're just not, we're checking for it. We're not handling it, if it makes sense. So we're leaving y as it is, and y is still an option here. But because we check up here that it's a none, like we're just gonna unwrap it. Because if we get to this point in the code, we know that y
It's not none.
is not none. And then we also have this. We used to use the power float, or exponential for float was this pow f function, because y used to be a float 64. But and this actually solves one of the issues we saw in field element. It's not necessarily one of the issues, but this, there was a function I thought we weren't using this somewhere, but anyway. So this would be to the, all right, what do we got here? So once we unwrap it, we get a field element. Excuse me. We're good. Thank you.
To the power of. Yeah.
I don't know why. Oh, okay. So the reason why this is not showing up in our code complete.
Sense or whatever. No.
Yeah. Do you know why?
I don't.
So it has to do. All right. So just compare that function to the other function we have that we have implemented for field element.
Compare this to the power of function with
new.
The one on the top there.
Yeah.
The init. You haven't like put the match in this one yet?
No, it's not public.
Okay.
So that's what this pub keyword is in front of the function. Is it basically, because otherwise this function is only available internally to field element. Internally might be the bad way to describe it, but essentially when we have a field element, you can only call functions that are public.
Okay.
Right? So because this was not public or are marked public, we can't call it. And it's a way for you to sort of guard against people using your code not in a way that you wanted necessarily, or like it sort of allows you to like compartmentalize the functionality and logic of your code, right? So if for instance, if we are exposing, for instance here, like we expose this to the power of, and we can change the internal logic of that function, and as long as it still has the same input and output type, the caller of this function, no matter if it's in our code base or in some other code base, the caller of the function doesn't have to change anything on their end. We can just update this sort of internal business logic, or not business logic, but we can update the logic of the function as long as it has the same inputs and outputs. Does that make sense?
Sort of.
This goes into like API design and like some other things around. What's the term for it? It's mainly around like API design, but then also there's a book called Clean Code that there's these principles, solid principles, something in there. There's stuff in there. It's been a while. I need to go back and read that book.
This is very Java-like, isn't it? To have the functions be public or private, or at least it's something that exists in Java.
Yeah. You definitely see this in Java. You see in a lot of other object-oriented languages. So Java, C# for sure have it. I don't remember if Go does. I haven't worked a whole lot with Go. But anyway, so now it's public, and so now we should be able to call it. And we need an eye size. And so this is going to, all right, hold on, save this and see what's going on. What is it complaining about here? Expected eye size, and we found a float. So this is just stale. We had a float before, so it's stale. We'll do essentially the same thing with X here. Again, because we checked if it's none already, so we know that it's safe to just unwrap it. There's probably some other thing to do that's more rusty, or like is more of a rustism to kind of handle this. But I don't know what it is right now. Actually, I think I know. Hold on. Is it a question mark? I think you can do question marks. The question mark can only be used in a method that returns result or option. Interesting. All right. And that's not gonna. Okay, so yeah, we're just unwrapping it then. There's like weird like markers like question marks, and I think exclamation points have like special meaning depending on where you use them. But what do we have here? Oh, this is X again. We need to unwrap X here. And this X is complaining because it's an option. Y is going to complain because it's an option. So we need to add the prettier print version of this. So that's fixed. So now we have, let's keep going down here. So this is complaining. Basically the same thing, prettier print version. And then this check is none. This check is none.
So kind of, we are using none. Like we figured out a way of using none.
Yeah.
Yeah, we need it in the end.
Yeah.
Interesting. Yeah.
Which, I mean, when we initially designed point, we were designing it for real numbers. So using the float and the infinity, I think like that made sense from like our point of reference. But yeah, now that we need a way to sort of have none.
That's so interesting. So cool. Like languages, how these fundamental concepts of none, infinity, and how each one will interface with that.
Yeah, and none, like so Rust doesn't have null, right? Which that's sort of like the none in Python, where you can have none all over. The only thing that
okay, so this isn't null.
It
So, yeah.
It is, however, you have to explicitly handle it. You have to check, is it none? You have to check, is it some, right? So that's like if you go look up, there's like some talk where it's like null is like the $1 billion mistake or something like that, because nulls in code bases have caused like just weird, crazy errors where like something doesn't work and nobody knows why, and it's because there's a null somewhere. And so, yeah, with Rust, it like forces you to handle, hey, this may or may not be a value. So like you need to do something accordingly, which it looks like we are getting. So this is an option. So the one thing is we didn't check if self.y is none here or not. Oh, I guess. Okay, so on the infinity point, are both x and y would be infinity, right?
Yes, yes.
Okay. Because I'm wondering if it's safe to just unwrap y here because x is none. Or if we should add a check like self.y here is none. We're just going to go ahead and do that because,
hurt.
Yeah.
I do remember looking it up, and when one was none, the other one, yeah, it was always both of them.
Yeah. And I only want to do this because I want to make sure. Oh, and here's something we can do actually. Instead of unwrapping in all of these locations here, we can just we can redefine x.
Because it's some wrapped version.
Right.
Nice.
And same thing for y. So that's cool. And then we can get rid of self. Oh, we'll need other. We can just call it self y. And then we can do other y. Oops. There we go.
How'd you do that?
There's so Control Alt and then up arrow gives you multiple cursors, and then you kind of like jump around with it. It's very nice. And then if you highlight a couple lines, if you do Shift Alt down arrow, it gives you a copy down, etc. Yeah,
that one is great too.
And then whatever you have highlighted, if you hold down the Alt key and press up and down, you can move the code.
Nice. Yes, code, man.
Yeah, I like. Are you gonna help me clean up some of these variables?
Mm-hmm. Yeah. Let me.
All right, let's do it. This is what live share is all about. All right. Seems like
that's where you are as well.
Yeah, Greg is signing off. Greg, thanks for tuning in, man. It looks like some people in the data space are going in on Rust as well. And Greg has a shout out. Stay humble, stack sats. Will do.
Thanks for stopping by, Greg. If you want to drop your handle on the chat there, I'll make sure to follow you. Thanks for stopping by.
For sure. I think I think I can DM you. I got his contact information. He's always down to connect with Bitcoiners. That's like that's all he did was he just was like, hey, I just want to connect with Bitcoiners. And I'm like, oh, sweet, man. And we talked probably for 45 minutes. It was fantastic.
Nice.
Okay, so we got an issue here where we've got, it's because it's a field element. So we got to check out the number.
Check out what?
The so we're doing self y, other y, adding.
Thanks, Greg. I'll follow you. I'll make sure to follow you back.
Perfect. we're adding field elements and we're comparing it to a non-field element. So we just need to check that out and update it. So this might make sense where we can define like a constant. Like field element 0, if that makes sense. And I believe the way we can do that let's see, 0 equals field element. In this case, well, we don't know what the prime would be. So we'd have to give it, I guess we could do, because we have to give it, we have to know what the prime number is for the field element in order to generate it. So we could do a function, I guess. What is it called? There's Rust static functions. So do you know static functions versus class functions?
Sort of.
Oh, I don't think it matters because this new one is not. It's like they're both. There's no such thing. Well, anyway, the idea of a static function, I don't think there is the concept of a static function in Rust, now that I think about it. But if we write the 0, we can take in just a prime, and then we're just returning this. Does that make sense? So it's sort of like constants, but it just saves us writing this over and over every time we want to reference the 0 element for a field. And so when we go back to here, we can do finite element : 0, and then just give it the not that. Self X is a field element. Oh, okay. All right. So this is, again, this goes back to sort of the what are they called? Not visibility. So the prime number is not a public field, right? So we could go here and we could just like make prime a public field, but then that means that you can modify, or not necessarily modify. A more appropriate way might be defining a function to get the prime.
Okay.
Right, where we are returning a usize, and all we're doing, we need self. Sorry, we need to pass in self to this. Oops. And all we're doing is just self.prime. And the reason we're allowed to reference dot prime here is because we're in that field element implementation, right? So it is not a public field, so you can't access it outside of the field element code, right? But if we add this function here, get prime, it's essentially the same thing, but it's not exposing that field to the outside world or to other sections of the code, right? Like, and so now this way, maybe we wanted to do some math before we give back the prime or something like that. But this allows you to basically, when you get a field on a struct, you can sort of define how that's handled. And the same thing with like setting it, right? Like if you wanted to set it, and that's a common pattern you see in I think most programming languages. Maybe not most. I definitely saw it a lot in Java, but Java's weird. Okay, cool. So let's keep moving. So this one, we just need to be field element 0. And we could probably define, because we've now typed this twice. What is going on there? Oh, because we didn't update this. So we typed this twice, so we could probably define this somewhere else. Just cleaning it up.
Good practices.
Well, it's like, where else are we going to use it?
Yeah.
And this might do something weird with self X, but it doesn't look like it. So now point. So this is this is the infinity point. So we do none. Right?
Mm-hmm.
Because we updated this to taking an option, so none is a valid option. All right, what is this complaining about? No method name for
Yeah, I did that one. I don't know if it was correct. I was following the previous model.
So here I would do self underscore X. Because we already unwrapped X.
Okay. But when I did self.x, I was still referencing the option back there.
Right. Yep. And then this is going to complain that we can't multiply float by a field element. So we will need to...
You can do
this is
just sum it to itself 3 times.
We could, yeah.
That's with a different example, yeah.
Yeah, we could. What was... where did 3 come from? Do you remember?
It's the slope equation is just... Yeah, so if you go to page 38... Oh, yeah, or that one, yeah. But 38, there is deriving the slope tangent to the curve.
Page 38. 37.
There you go. Yeah.
Oh, yeah. Okay. All right. I remember this. Because I think we glossed over this.
Yeah, because we didn't want to get into the calculus, the derivatives.
Right. So we're this is the part where we're trusting verifying. So when I get to this with my notebook though, I'm gonna do it, and I'll report back.
Proof of work right there.
Yeah. Oh, okay. Yeah, we'll just add it to. We'll just that seems really hacky, but I like that a lot. Just because it's easy. And sometimes you just write the code that's the easy code. Uh-oh. Doesn't like it though. expected. Okay, hold on. Let's all right, we're adding plus self. Why is this is complaining about things. Oh, we need self underscore y. Expected. Oh, duh. It's because we gave. All right, so this is going to be weird. The slope.
Oh, remember, yeah, the slope is a float, but it is that. Yeah.
And it remains a float, right? So we're going to need to figure out okay. So I think all right. I think I know what we got to do here. So we do want the slope to be a float because a slope is a float, right?
Yeah, I don't think we want it to be a finite field element.
Right. But what I think we need to do is create a way of we'll add another function to our field element to get the actual number itself. And I think that will allow us to do the calculation. So almost exactly like get prime, but instead of get prime, we'll do
Get num.
right. Well, we'll do get number.
Okay.
And then, yeah, right where you're at, you should be able to do get number. No, at the end of to the power of.
Okay.
Yeah, right where your cursor's at.
Get number. And then are there any parameters? No, right, it's just self. Yeah.
Yep, it's just self. So now this should complain that we're multiplying a float by u size. Yeah, I cannot multiply a float by u size. So we can just cast, because a float takes up more memory space. Well, yeah, u size. So it's unsigned. I don't want to just cast that as a float. But because we don't need it to be a float necessarily here. We don't need this to be a float. And A is going to be also a field element. All right, so let's see how this goes.
Nice.
So all of this.
And same thing with the 2.0, right? You can just unfloat this.
Right. Yeah. And then we'll get the number of self.y basically. All right, what's this yelling at here? Expected. Okay. Yep. So there is a way. I think so. Going from a U size, because this is a U size, and we're trying to assign it to a float 64.
Can you just make slope a U size instead?
Oh,
Since we just defined it.
Yeah. Yeah, because we shouldn't have any. These are all U sizes in here, so.
Nice.
Yeah, you're right. You're right. You know you're right.
Yeah, boy. these new functions that you created are super cool. Like just basic stuff, but they get the job done. Get number, get prime.
Mm-hmm. Oh, I don't. Actually, I think we were supposed to. What was this complaining about? Oh. Because at the end of this, it's a field element, so we should just. Why is that complaining? Oh, it's decimal there. Oh, okay. All right, I see what it is. There we go. We just needed to put parentheses around the whole thing.
Okay.
Because this slope calculation was just between finite fields, so the arithmetic worked out already. This one, because the slope calculation had external numbers that weren't finite fields, we needed to do the thing. And then I think now, so slope is now u size, so I think we can just use regular power. And I don't think we need this. And so this is x. Oh, okay. So this is the new x and y coordinate. So we'll need to do some other conversions here on the back end of it, I think. Does that make sense?
Yeah, I think so.
Do you see where it's yelling at us now? Now that we've changed x?
Sort of. So you made self.x, self underscore x, yeah, no, I'm not entirely sure.
So, okay. We just we changed this, so we had the slope, right? We did slope to the power of 2. We removed the float from 2. And then, self.x, because self.x is no longer a float, we had to do get the number for it. The same thing with other.x, and this gives us the new x coordinate. But what it gives us is the u size of the x coordinate. But where we're using this x is we're returning it as a point. So basically what we'll have to do, do you see what we'll have to do?
Mod it to the prime to put it back in the finite field.
No.
Not even. But like turn it back into a finite field, or not?
No, it doesn't have anything to do with finite fields. It only has to do with
Elements.
the typing of. So this point new function. Right, you can just read this compiler error, and then I think.
Okay. Expected option found u size. Yeah. So you want to, make it an option entirely, not just a field element.
Well, we want to make it an option of field element.
An option of field element.
That's what, when you see the angle brackets around a type, that's like, they're called like generics, I think. You see it in a lot of programming languages, but it's like, hey, this is an option, and this is the type within it. There's,
Okay.
I don't know how to explain this right now, but like you can have an option of any type. You can have an option of u size. You can have an option of F64, right? And it just kind of tells you the internal like typing for it.
And an option in its turn, it means that it can be some or none.
Right.
That's what an option is.
So this is
So how would you turn a use size into an option of finite field? You have to create a new uh, so you're gonna create a new finite field element object at the end of the function based on the use size.
right.
So you're gonna run the finite field class again. Yeah, like instantiate one more object.
Yep.
Yeah, nice.
And what we'll do is, so there's a quick, so sum, right? So it's a sum of,
It's definitely a sum because the nuns were dealt with like at the very beginning of the class.
exactly, yeah. And we're at the end here where we have the value.
Yeah, exactly. So that
Did we grab,
field element.
oh, we did have prime. Cool. Oh, we don't want that. This is supposed to be 0. Ooh, man. We almost screwed up there.
We were using prime for other.
We were, yeah. And so, I mean, it doesn't matter where we get it from, but we can just do like self.x.get prime.
Okay.
Should work fine. And so now we have, you can see that it kind of gives us the type, the inferred type of x now.
Mm-hmm.
And the reason why this allowed us to do this is because we use this let keyword again. Like if we take this out, it's going to yell at us. And it's going to yell at us and say, oh, no. X is supposed to be of type U size. But if we put this, it allows us to kind of like overwrite X to this new type.
Mm-hmm.
Because we're not using X again afterwards. So like it doesn't really matter.
Yes.
But yeah, and then we can do the same thing for Y. Just for posterity, we'll just use Y there. And so now when we return the point, X and Y are now options of field element.
They're already options, yeah.
Right. Yeah.
Self.a, self.b, then not much happens to self.a and self.b.
No, yeah, those are fixed, right?
Mm-hmm.
Those are fixed numbers in Bitcoin.
Yeah.
0 and 7, right?
Mm-hmm. Our SECP 256 K1.
Yes. Okay. Wow. Questions?
Do we have it? Does that mean that
not yet?
You can.
So we have to refactor all of our tests.
Okay. Yeah, this will be a good exercise.
So you tell me what we need to do to refactor this test.
Okay, bad point. So you want to make x, y, and a and b finite fields.
Yep.
So we have to define the. Oh, interesting. Yeah, we don't have a prime for these numbers, right? Because if we are creating a finite field, we need a prime for them.
So we can do. I think we can do something like that. Or use size. Right. So we can just use a prime for our test cases. We'll just use 7 because whatever. All of our numbers should be. I guess we'll go a little bigger than 7.
Yeah.
Because we have. Yeah, we have.
77. Okay.
Right. So, what's a high prime number?
191.
Is that a prime number? Do you know that for a fact?
I think so, right? You can't find something to divide it. An easy division with 1.
Yeah, I don't.
Maybe I'm wrong. Could be like 13 or something. 13 times 7, no. That would be 201. There we go.
Yes, 191 is a prime number.
Okay.
You win. All right, so write
all of them.
the code.
Okay. I need to
Now,
recall
go up to.
sheet of field element. So
Yep.
well,
I can help.
this would be
Just ask what you don't remember. Yeah.
new. And our prime. Do I have to capitalize it like this?
Mm-hmm.
Okay. Missing something here. No, that's it, right? Yeah. This. Oh, I copied too much. Okay. Prime.
I'm gonna move your cursor.
Seven prime.
All right, so we still have a couple of issues with this. One is we're just missing closing parentheses, which is kind of why I want it. But so why is this unhappy here?
Expected option. All of those are options.
Not
We
all of
need
them.
to optionize them. Just X and Y.
Right.
Like this.
No, not like this. So it will with this you'll want to use some because there's actually something here. So it's either going to be some or none when it's an option.
Already declaring.
And sum is sum is actually a function. So you
okay. And the field element would be the parameter.
Right, and then there's one other thing that's not going to like.
Oops, I expected 4 arguments.
So yeah, that's just because we forgot to close this out. The 4 arguments one should go away.
Okay.
Mismatching, closing delimiter. Where did that go? Hold on. There's some.
There's extra parentheses. Oh, that's the parentheses that's missing here.
No, not there.
Not it. No. Oh, okay. Sorry.
Okay, there we go.
And we don't want the floats here, right?
Correct.
Or is it okay to have the floats here?
We don't want floats. It also doesn't like other things. So we hit save.
No negative. Oh, use size is unsigned, right? So.
Right.
Right. So, how do we do that?
So save again. All right, this appears to be working.
But if I just made them positive, that doesn't invalidate the actual example. Like, isn't it a different point?
We can find out. Let's comment out the rest of the code here so we can run it.
Yeah.
And then
have to run.
We'll run the test.
Passed. Okay.
So that worked.
Because they're mirrored over this mid-axis, right? So I guess it's the same.
Yeah. I didn't even think about that. Yeah.
No. Okay.
I didn't know if it was gonna pass or not. Like I was just like, yeah, let's see if it works.
It's in the curve. Yeah, we have many more examples to test. See if this holds.
Well, yeah, you have to convert all of these other points to.
Okay, so now I think I have the 2-point new. -1 prime. -1 prime. Am I doing this correctly? I think.
We'll find out. Just keep
Yeah.
doing what you're doing.
Yeah.
We'll go back and look at the terminal, and the compiler will tell us what it doesn't like.
I have to make them positive now.
Yeah, and I think that's going to change probably our math. Don't forget that sum, you have to close out the parentheses
One
on
more
sum.
parenthesis.
Right. Yeah, I
Okay.
gotcha.
Okay, so it's like a whole function for
Mm-hmm.
very end of prime. Yeah.
Beautiful.
Still, no, it's not. Okay.
It did sort of arguments found integer. All right, hold on. So this is where I like to break things out like we did above with the point. So with a point new, and we have sum. We have sum. Oh, you didn't convert the last two numbers here to field elements.
Ah.
And it won't be a sum, right? Because it's A and B are not options.
Not options. Yeah.
Yeah.
Thank you.
And it's probably
Two less. Yeah.
similar.
Oh wait, we needed that one. Yeah.
Yeah, that's why I like to do the indentation.
Mm-hmm. Same thing here. Yeah. So
Mm-hmm.
5 and 7 should be not just regular field elements.
Yep. Cool. Now those work. So let's go through and finish up, kind of changing all these. So this is 1 and 1. So we actually had that defined already. So we can just grab that.
Same point.
Right.
The other one. Oh, okay.
And this is now none, not infinity. And then these.
So if you just give none, does it have to be like field element none?
No.
No, right, it's just none, because the option is in the very beginning of the
right
instantiation. Nice, yeah, that was the good call there, the right call.
Okay, so we got a few more down here.
Okay, you wanna do the top one and I'll do the bottom one?
Perfect. Yep.
And we have some overlapping here, so I can grab. Yeah, these are all the same. This is column. I need this. B2, same thing. Oh, but I got the wrong point, I think.
Yeah, it'll end up just being
With ones, right? 1, 1. Yeah, I'll correct it.
All right. I'm hands off.
I think it's this.
Well, no, the stop one, the P1 was a 2.5.
I don't think so. No, I think I pasted the wrong one. Check this out.
Oh, did you?
Yeah. This is how it was before.
Okay. Yep. Got it.
My bad.
Hey, you're good.
And
We caught it.
expected. Anyway, let's just do this. Yeah. If you wanna jump in. This would be some.
Right. Nice.
Okay.
So I'm anticipating some of these tests to be broken. Okay, so we do have some points up on line 169 is gonna.
Like brain workout.
Yeah, it's kind of weird having it edited at the same time, because like jumping all over the screen, all over the screen. What did I do here? Oh, I missed the prime. All right, sweet.
You see something here? The new.
What is it? What are we missing?
Oh no! It took a deep breath. The compiler. No, it's
Yeah, compiler's trying to keep up.
exactly.
Okay.
4 hands.
We only have an unused variable, so that's good. And it says if it's intentional, prefix it. So, perfect. Now there's no problems detected.
Look at that.
Woohoo! Let's run tests and watch them all fail. Because we just updated some core logic. Or maybe they won't. I don't know. Oh, yeah, there's. So add doesn't work. Equals doesn't work. Okay, so this makes sense. And I think if we look at. Right, so it's basically because, well, I think we just have it, like the 1 plus 1, or let's see I wonder which parts of. I wonder if it tells us which part of add test doesn't working out. So let's actually break these out into separate tests. Because we have an assertion here where it's add to itself. We have one where it's, an exercise or whatever. So let's break some of these out. Where we can do add, and this is identity test. Identity. Right, and we can leave these assertions here, and then we can add another test. Add test, and so there's an assertion here. Add self test. Right, so now we kind of have these tests broken out into the various assertions, and so we can have a better idea of like what's actually broken when we run them, because each of those we're testing a different functionality of the code, right? Oh man. Okay. All right, hold on. Let's go full screen. Let's see. All right. If we run point tests. Okay, so all of them failed.
Oh.
So we can go one by one. So the equality no longer works. So let's figure out why that no longer works. So what are we doing in the equality?
One of the tests passed, right? Oh, we do have one that passed there.
We
Which was
do.
the very first one.
Yeah, creating a bad point. And it passed because it panicked, which we wanted it to.
Okay.
So yeah, let's just run this equality test and see if it gives us some more explicit output. So it panicked. Because it's not
Not
on the curve.
Likely
That
because of we flipped it, made the sign.
yeah. But a finite field so is it
What I think is that these tests weren't made for finite fields. Like these tests were made for adding points for in real numbers.
right.
Reals.
So basically this is it's panicking here where it's saying it's not on the curve. So what is this doing? This is checking if A is equal. So it's just checking if A and B are equal. Or rather not equal in this case. So for whatever reason, this is saying that A is not equal to B. Or, hold on. Split right. It's getting late. So yeah, other A is not equal to self A. But these two should be equal. They're both in the same field. They're both the same number. And this is field element comparison. So we go back here. Self dot number is equal to other dot number. Self dot prime is equal to other dot prime. I'm not exactly sure why. Oh, I want. It's probably in the. Self dot A and self dot X equal to other X. So this is where I think I would want to debug. So you can, no, I don't want to do that. What is? All right.
You think these should work? These tests should work, even though we're kind of turning them into finite fields.
Yeah, I think so.
They weren't expected to be used in finite fields.
Yeah, so all we're doing is comparing 2 points. So does A equal B, right? And in this case, like,
It should,
yeah,
because they're literally the same point.
right.
Okay.
But then it yells at us that it's not on the curve for this point. Right. So, and that's the check where we're just checking to see if the other point
Aren't
given.
those aren't those the ones we changed from -1 to 1?
Or I'm sorry. No. Oh, never mind. Never mind. Okay. Yeah, I'm tired. Once this is the add. This is the add implementation. The actual error we get here is under the new, like when we're creating a new.
Like in the very beginning, like
Right.
just checking.
Right. Which makes, okay, and this makes perfect sense because we have this test here that says, hey, this test should panic. And we give it this. Well, we don't give it this. But I bet if we give it 1, 1, like this test is still going to pass. Because it should panic because it's not on the curve.
It's a really easy test.
Right.
There we go.
So I think we need to find out which numbers are actually on this curve. But I don't think we're gonna do that tonight.
Yeah.
Because my brain's a little fried right now.
Same. You did most of the work with this refactoring, crazy refactoring there.
That's what we're here, man. This is. I hope it wasn't too crazy. I mean, were you able to follow along, or was it too?
No,
too much?
Totally. Yeah, no, following the
Okay.
type, the castings and changing types, and then bringing it back to a finite field at the end. That was great. That was epic.
So we need to. What did we do here? We didn't do anything here. We can get rid of that. So let's commit our changes before we leave.
Sounds great.
Oh yeah, we do.
So to find the points and to create some tests, you would like plot this curve in like the Dasmos website, for example, to find the actual points.
No, because we're plotting a finite field curve now.
We don't know if it will accept it.
So
maybe that's one of our next challenges.
Right, and maybe that's, honestly, maybe that's in the book. Maybe that's part of what.
Like actually plotting, yeah. If you go to page 43, there is a curve plotted. Yeah, that one.
Right.
It's total scattershot.
But it's okay. So we can see if it's on the curve. And you know what we'll do? We'll update the tests to use the Bitcoin elliptic curve. So we'll use A0 and B7 or whatever.
Nice, yeah.
But let's review. All right, so, and this will be good because we can kind of review what we've changed so far before we commit. Which we might not. You might want. There's lots of opinions on Git and like how often you should commit or anything like that. But like, I would argue almost that just changing this, make that a commit, right? And that way you make these small commits and then it's easier to like undo something if you broke it, sort of thing. So like normally I would, not normally, it depends on how fast I'm going and what the actual use case is. But like I probably would have committed this line as its own thing, commit each one of these functions as its own thing, commit this as its own thing. And then you can get very explicit in your commit message on like what happened. But for right now, we can just add it and just say, so derive, copy, and clone for field element. What else
So
do we do?
your commits kind of work like commenting the actual code.
Yeah.
If you were to add comments on top of each function
Yep.
describing what it is.
Yeah, and that's another. Like I said, there's a whole like philosophy to Git commits, where it's like some people are like whatever, just like do whatever works. But if you can break it down into smaller chunks, then you can be more explicit and you can really read the log of like what happened, like what changed in your code. So like some open source projects will like if you have a bad commit message, like they're like, nah, dude, go fix that.
It's not the code, it's the actual commit message.
Yeah, like it's like if you put I changed a thing and that doesn't mean anything, right? So people get very particular about that.
Yes.
And like this is a very vague Git message too. Like you could also elaborate into here, like, why did we need to derive copy and clone?
Mm-hmm. And the reason why it tells you when it's above 50 characters is because like on GitHub you only see the first line for
I
each commit.
think so. Yeah, I don't know why.
Yeah.
Oh well.
Very small monitors, 50 characters only. Very narrow monitors.
Right. And then we made to the power of public for use outside of FieldElement.rs. Cool. I'll commit that. And then what do we change in point? We changed a bunch in point.
Oh yeah.
So yeah, this sort of refactoring is like where do you break it up? So we'll break it up here and we'll leave actually let's not commit broken tests. We'll wait until we come back and we'll fix these tests up and we'll go from there. Cool.
Yeah.
Cool. Well, for anybody watching in the future or right now, thanks for hanging out with Pleb Lyra and myself, doing some programming Bitcoin and Rust.
Yes.
Stay
Thanks
humble.
for watching. All the other bots out there that are decoding what we're talking to build chat models.
Yeah. To build
Good use of it.
the Pleb Lyra deepfake.
Exactly. Yeah, it's all there.
Oh man, you know what I just realized is on OBS on the stream, I've got our Twitter handles reversed.
Oh, well.
Oh well.
Works the same.
Yeah.
I hope they follow both of us.
All right. Thanks everybody.